Hello my dear students, welcome back to NEET WORLD. So today we will be discussing electrochemistry. So this is our part 3 on our electrochemistry discussion right now. So these sessions are highly helpful and it is designed for EAPCET as well as upcoming JEE exams. Okay. Now if you are preparing for EAPCET 2026, so these sessions are for you. Okay. So now in this session we will be discussing concepts first. Okay, particularly here I am discussing about conductance, conductivity, resistance, resistivity and the relation, cell constant, electrolytic conductance. Like this we will be discussing slowly one by one. Okay, molar conductivity, equivalent conductivity, all these topics will be discussed along with their previous year questions from EAPCET as well as JEE exams. Okay, few NEET questions will also be added here. Okay, and one more thing guys, if you haven't watched my previous session on electrochemistry, just go to the playlist of this channel, like live sessions you go, so there will be EAPCET 2026 chemistry subject. Okay, I mean you can watch it, complete playlist will be there for EAPCET 2026 in the playlist list of this channel. Just go and watch it. Yes, definitely those are highly helpful for your preparation, right? So here what exactly here, so in the last session I told you there are two chemical reactions here, chemical cells. One is electrochemical cell, another one is called electrolytic cell. What I told you, one is electrochemical cell, another one is electrolytic cells. Okay, this discussion is already done for electrochemical cell. Then next we need to discuss about electrolysis. Yes, we will discuss this once after finishing our discussion on this conductors, resistance, what all these things, conductivity, resistivity, all these things today we will be discussing. Now what do we mean by conductors? Tell me in a basic generalized words, whatever the way you know, just tell me. We know those substances which allows passage of electricity through them is considered to be conductors. What I am saying, those substances which allows the passage of electricity through them are considered to be conductors. Okay. Now what are the examples we have? Conductors can be of two types. It can be metallic conductors. What I am saying, if it's a simple metal, then if it is conducting, if it is a conducting metallic substance, then you can say it's a metallic conductor, or simply call it as electronic conductor. What I am saying, electronic conductor. And one more we have, that is electrolytic conductors. What I am saying, this is electrolytic conductors. Okay, so in chemistry we will be most like now we will be dealing with these electrolytic conductors. Okay, because here it involves chemical substances. Like electrolytic conductors means, for example, you are taking aqueous NaCl solution. For example, this is one example I am saying. See, if you take pure water, what I am saying, in a beaker you are taking pure water, will it allows the passage of electricity? No, right? Why? Because there is no ions, because it's a very weak electrolyte. Therefore water, pure water is considered to be a bad conductor. But when you add NaCl to this, NaCl salt to this water, what happens? Now Na plus Cl minus ions are formed. So now this chloride ion and sodium ion are responsible for their conduction right now. So what are the ions responsible here? Cation, anion are formed. So those free ions are responsible for this conductivity of these electrolytic conductors. Not only NaCl, you can take any electrolyte. For example, all acids are examples for strong electrolytes. What I am saying, all acids, all bases are examples for strong electrolytes. I am saying these are all strong acids. Strong acids and strong bases are examples for strong electrolytes. Okay. Now all weak acids and weak bases are examples for weak electrolytes. These are for strong electrolytes, these are for weak electrolytes. Give some examples here. So NaOH here, HCl here comes under strong electrolytes examples. Weak acid like acetic acid, ammonium hydroxide is a weak base, comes as a weak electrolyte case. Okay, right. So now what are the responsibility, I mean what species responsible for electrolytic conductance here? Their free ions are present in this electrolytic solution, that makes it to be a good conductor. So what is the charge carrier here? Free ions are responsible here. Okay. Now when it comes to electronic, that is metallic conductors, you just take any metal substance. For example, I am taking here a metal and its surface. So on that surface these metals are arranged like this right now. So assume that there is one atom, this is one atom in the lattice. I have taken this metal lattice, from that we have one atom here. So we know atom has a nucleus at the center, around we have electrons, right? Now around we have like around this nucleus we have electrons. Now that electrons will be, some are close to the nucleus, some are far from the nucleus, like this. As we move away from that, so electrons will be like at some distance, right? Now there is something called valency electrons, right? So during the chemical reactions, what we know, only this valency electrons of metal will involve. This inner electron, that inner electrons of metal won't involve, right? Only valency electrons will be involving. Only valency electrons are involving means the inside part which is not involving in the reactions, no? So that part, that inner core electrons plus nucleus together called as a kernel. The kernel of metal, we can call it as inner electrons plus metal, I mean nucleus of that metal, okay, kernel. What I am saying, this is a kernel, okay, and this valency electrons which are participating in chemical reactions and which are responsible for electricity, passage of electricity. Now what are responsible ions or species here? The valency electron, the mobile electrons of these metal atoms in the metal lattice are responsible for conductivity of this metallic conductors, okay. Who are responsible here? Mobile electron. See, there will be, this is a nucleus, 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 nucleus of each atom. Around we have some inner electrons that won't involve, only outer valence electrons which can be considered as mobile electrons responsible for the electrical conductivity of these metallic conductors, okay. Now what is the factor here? I am saying when we increase the temperature, this is factor affecting conductivity here. So when we increase the temperature, now what happens to the conductivity or conducting nature of these metals? What happens when we increase the temperature? Kinetic energy of that particles increases, right? So due to that, the vibrations in the kernel will be raised, okay. When kernel is vibrating, now that will makes it to be a less conducting substance. So when you increase the temperature, conductivity decreases, conductivity or conductance decreases. For which one? It is for metallic conductors, okay. When you are discussing about electrolytic conductors, so if you increase the temperature, what happens? The ions formed will be easier. See, for example, whether you take weak electrolyte, whatever you want, but when you heat it, what happens? It will dissociate easily, right now. So when it is dissociating easily, we will get more number of ions. More the number of ions, more will be the conducting capacity, right now. So upon increasing the temperature, conductivity also, or conductance also, or conducting power also increases, okay. So this is a statement valid for electrolytic conductors, and this is a statement valid for metallic conductors. Very, very important statements these are, okay. Try to remember, and if it is clear, please click on the like button, and also you can express whether it is clear or not. If you have any confusion, please feel free to write in the chat box, okay. If there is any confusion, please mention in the chat box. If no confusion, please click on the like button, right. Next here we need to discuss, yes, metallic conductors are over. So with the rise in temperature, magnitude of metallic conductance decreases. Right now just we have discussed, right. Look at this. When it comes to electrolytic conductance, this is what electrolytes will show. So now what happens upon increasing the temperature? So upon increasing the temperature, their ionic conductance also increases. This is what we discussed. Now what are the factors affecting electrical conductivity of electrolytic solutions? Now from now onwards we are discussing about electrolytic solutions. This means electrolytic solutions are nothing but electrolytes. Just now we discussed weak acids, weak bases, strong acids, strong bases, or salts are some examples for electrolytes, right now. So now here inter-ionic force of attraction, greater the inter-ionic force of attraction. It means if you take a salt, there will be a cation and there will be an anion, okay. See here, larger the solute-solute interactions, lower is the extent of dissociation. If these two ions are very close, if they are not undergoing any dissociation, there is less number of ions forming. Then if there is no ions or less number of ions, lower will be the conductivity. So here you can see, larger the solute-solute interactions, lower is the extent of dissociation, then lower will be the conductivity for that particular solution, right now. So if solute-solute interaction, these ionic interactions are more, then lower will be the dissociation, that's it. If lower dissociation, less number of ions, less will be the conductivity. That's what you need to understand here. Okay guys, do not by heart the things, always try to learn the concept here. Okay, next, what about solvation of ions? See, solvation of ions is nothing but if, see, here I am taking the solution here, like water in this. First of all, I am taking water here, which is our solvent. So solvent, to that I am adding a solute, like electrolyte we are adding. Let us say KCl we are adding. Okay, similarly we can add KCl, or we can add NaCl, or we can add rubidium chloride, like RBCl, like this we can add right now. So in this case, which electrolyte will be having more conductivity, they will ask. So how do you answer? To answer this kind of questions, just look at here. What are the cations I have taken here? K place, Na place, and the next Rb place. This kind of ions I have taken. So all these ions belongs to same group now. Yes, this all belongs to same group, that is first group elements right now. So down the group, what happens to the sizes? First one is smaller, little bigger, little more bigger, and this is larger, like this right now. So now what happens is, we are keeping these ions in the aqueous medium. What we are doing? We are keeping these ions in the aqueous medium, and now I am asking which ion will be more conductive. So which is having more capacity, conducting capacity I am asking. Now in this case, what you need to check is, you need to check for the ion, the solvated ion size of these molecules. So now what I am writing here, the conductivity here. So I am writing, see here, conductivity is inversely proportional to solvated ion size. Solvated ion size. Why solvated ion size? Just look at here guys, all of them are +1 charge. Okay, so now smaller ion, lithium ion is smaller ion. So if it is smaller, lithium ion is smaller, now what it will do? It will attract more number of water molecules like this, because small size means more nuclear force. More nuclear forces means more effectively it is dragging. If it is dragging more effectively, all these electrons of oxygen will be polarized towards lithium side. It means lithium ion is perfectly surrounded by the water molecules around it. Therefore, which is hydrating more, which ion is getting hydrated more? Lithium ion is getting hydrated more. Okay, so as we go down the group, the size, the hydrated ion size, normal sizes if I ask, cesium ion will be bigger size. But now what I am asking, when we place these ions in the water, they get hydrated. Therefore, which ion will get more hydrated? Lithium ion, because of its smaller size. So now when it is getting more hydrated, now you need to consider the hydrated ion size. So which is more hydrated? Lithium ion na? So if I ask for hydrated ion size, so I am writing here hydrated or solvated ion size. The order will be reverse of that above case. So what it becomes? Lithium ion plus aqueous will be greater size. The next here, sodium ion, the next potassium ion in the aqueous medium, next rubidium ion, like this you need to write. Okay, hope this is clear. So which is greater size? Solvated ion size is greater for lithium ion. So if this solvated lithium ion is larger size, it has a lower conductivity, like inversely related to each other. So this is what you need to be clear with. So if this concept is clear, please click on the like button and tell me, is this clear or not? Okay, just to check, ion, hydrated ion size, if greater the size, hydrated ion size, lower is the conductivity. That's it. This is what you need to remember here. Okay, now this is having bigger hydrated ion size, so lower conductivity. So if I ask conductivity nature, so this will be the order, like rubidium plus aqueous will be more conductive than the potassium plus, like this you need to answer. Okay, then next, what about viscosity of solvent? We know viscosity means the hindrance or resistance to flow right now. So when there is more viscous, when it is more viscous, what we can say, larger the solvent interactions, larger will be the viscosity. Okay, if the particular substance is more viscous, lower is the conductivity of that electrolyte. See, larger the solvent interactions. If solvent interactions are greater, See, solvent interactions are greater. It means they are having more attractive forces. Now what happens? They have very less ability to flow right now. So there will be more hindrance. Resistance will be more to flow. If there is less flow, the mobility of ions will be low. If mobility of ions is low, means conductivity also low. Okay. So greater the solvent interactions, larger will be the viscosity and lower will be the conductivity of that electrolyte. Okay, remember this. Next, concentration. Yes, for about this concentration we will discuss later. Then next, look at here, temperature. So what we discussed for electrolytic conductance, conductivity increases with increase in temperature, because upon increasing temperature dissociation will be favored. If more is the dissociation, greater will be the conductivity of that electrolyte. Okay, right, this is also clear. Next here is we need to discuss about conductance and conductivity. Before that you need to study about resistance and resistivity. So what do we mean by resistance? Tell me guys. Resistance. So resistance, let us indicate with symbol R, and from here the units for resistance is ohm. Okay, I am writing ohm. Okay, so now what we know, resistance means hindrance, or resistance means what? Hindrance to flow of electrons, I mean here electricity right now. So this in electrolytic solutions, resistance is directly proportional. Here in this electrolytic solution, whether you are taking electrolytic solution or normally electrodes if you consider. So what I am saying here is, resistance is directly proportional to L, length. So that is nothing but distance between these two electrodes. Okay, and inversely proportional to area, cross sectional area of these electrolytic solution. See here electrode plates are there now, so they have some cross sectional area, right? So that is what I am saying here. What is the area here? That is what here you need to mention. So from these together we can say R is equals to, or R is L by A. R is proportional to L by A. So R is equals to rho into L by A we can write. So what is rho here? Rho is called resistivity. What I am saying, rho is called resistivity or specific resistance. See, the word itself saying specific resistance. What do we mean by specific resistance? The resistance offered by a unit length and a unit cross sectional area of a substance. That is what? The specific resistance. Okay. So now they will ask what are the units for resistance and resistivity. See, already I told you for resistance it is ohms right now. Then for resistivity they will ask. So what you can write? Rho is equals to R into A by L right now. So from this, R means resistance, I mean ohms. Here L means, A means cross sectional area, that is centimeter square or meter square. Here it is centimeter. Okay, remove, so that you will get rho. Units of rho is nothing but ohm centimeters or ohm meters, depending upon the units you are using, whether SI or CGS, you can use this. Okay, hope up to here the discussion is clear. Right, let us discuss few more things. Now you got the resistance now. So what is that resistance formula? So R is equals to rho into L by A we are writing. Rho into L by A we are writing. Now the inverse of resistance, what I am saying, the hindrance to flow is called resistance. Now there is no hindrance. It means opposite of resistance is called conductance. I am indicating with symbol G. Okay, so it means I am taking reciprocal of this resistance R. This is nothing but 1 by R is called our G. G is indication, that is reciprocal of resistance is called conductance. Inverse of resistance is called conductance. Okay, so now you take resistance, I mean reciprocal of this complete equation. So this is 1 by R, this is rho, right? So it becomes 1 by rho. This is what happens, A by L it becomes, right? So up to here it is clear now. So 1 by R means I told you G, that is conductance. G means what? Conductance. You are studying now about conductance. Okay, so now how can you define this conductance? The conducting power of all the ions present in the solution can be considered as conductance here. Okay, right. Now 1 by rho, what do we mean by 1 by rho here? So 1 by rho is nothing but this is inverse of resistivity, right? Resistivity, here I am writing 1 by rho. See, this is resistance, this is resistivity. Inverse of resistance is called conductance. Inverse of resistivity is called conductivity. What I am saying? Conductivity. So 1 by rho is called K, kappa here. So K indicates what? Conductivity. Okay, you can say it as conductivity. Okay, right. So you can write here conductivity K, and this one as it is A by L. Okay, right. Now you can see what I am writing, K is equals to G into L by A I am writing. What I am writing? G is equals, K is equals to G into L by A. So now what about this L by A? See, when you are talking about the cells, so just look into the cell, see the length, the distance between two electrodes is constant, right? So this distance, let us say L, and the area of cross section of this electrode plate is A. Now what you can say, for a particular cell, the distance between the separation of electrodes, this will be a constant value, as well as the electrode, the cross sectional area of this electrode plate also a constant value right now. So the ratio of two constants value will also be a constant right now. So this L by A is a constant value, we can say as a cell constant. For a cell, these values are constant, therefore it is considered as cell constant. Okay, now the cell constant, let us indicate with the symbol G star. Okay, so that's it, we got final equation, K is equals to G into G star. Yes, this is an equation you need to remember, and there are many questions asked in NEET, JEE and EAPCET from this particular relation itself. Okay, right, let me show you few questions related to this equation. Okay, guys, patiently be sit at a place, try to watch it completely, definitely you will learn something new. Okay, right, if the things are clear, just click on the like button and you can mention your like any doubts, queries or your feedback in the chat box. I will be looking into it definitely. Okay, let me show you some questions. Okay, so based on our understanding from the previous discussion, whatever we did till now, just tell me for this EAPCET question, you can easily answer, guys, do not worry about it, you will definitely answer it. Just look at here, given below are two statements, assertion and reason. First assertion is conductivity of an electrolyte decreases on dilution. See, what do you know about dilution? See, there is something called Ostwald dilution principle right now. So Ostwald dilution principle says the degree of dissociation of a electrolyte, of a weak electrolyte, will be inversely proportional to, okay, will be inversely proportional to its concentration. So lower the concentration, greater is the degree of dissociation. So now once again read conductivity. See, this is about degree of dissociation. You no need of studying even about degree of dissociation also. So here they are asking only about conductivity. Now conductivity means K. Okay, now what do we mean by K here? You are taking, this is an electrolytic solution. Now the conducting power of all the ions present in this electrolytic solution in the complete beaker is called conductance, that is G. But here not asking about G, they are asking about K. So K means the conducting power of all the ions present in a unit volume. Like if this is a unit volume, now in this unit volume, what is the conductance? That is considered to be specific conductivity. Okay, what I am saying, specific conductivity. Okay, remember here this specific conductivity. See, if you add solution, if you add water to it, if you are adding water to this electrolytic solution, what happens? Volume of the container will be, volume of the liquid in the container will get raised. Right now you are adding only water, so it means you are diluting the solution. When you dilute the solution, the number of ions present in this unit volume, what happens? Previously, let us say there are 5 ions in this small area, that is unit area here, unit volume here. So now what you are doing? You are adding water to it. Now what happens? The volume, like whatever the quantity is there, quantity is getting raised due to addition of water. So overall quantity is increasing. Now the number of ions present in this unit volume will decreases. Why decreases? Because when you are increasing the volume, when you increasing the quantity of water you are adding, that ions will be freely moving here and there. No? So it means the number of ions, previously let us say 5, now it might be a 4, 3 like that. Therefore what I am saying, upon dilution conductivity decreases. What I am saying, upon dilution the specific conductivity decreases because of number of ions present in unit volume will be decreased when you compare with the previous. Okay, so what they are saying, conductivity of all the ions, conductivity of an electrolyte decreases on dilution. Yes, this is correct. Okay, next, on dilution, number of ions per unit volume, what happens? Number of ions per unit volume decreases, right? But they are saying it is increasing. So reason is incorrect, assertion is perfect. Okay, so A is correct but R is not correct. This is how you need to answer the question. Okay, right. Let me show you a few more questions related to our discussion. Whatever we did till now, we will discuss that. Yeah, molar conductance, yes, we will discuss molar conductance about that, just a minute. Before that, let us discuss this question. See, if the resistance of 0.1 molar KCl solution in a conducting cell is 300 ohms, it means the resistance is how much? 300 ohms. Okay, then next, what is the concentration of KCl provided here? 0.1 molar. Okay, and then next here, conductivity is given as K. Conductivity means symbol we used is K, that is 0.013 S Simon centimeter inverse. Okay, so this is also a unit for conductivity. Okay, inverse of ohms, ohm inverse we are writing now. Yes, you can indicate with capital S also. Okay, then the value of cell constant. So value of cell constant is nothing but G star. So what is the relation between G star and K? So we have a K is equals to G into G star. So now what is G here? G means conductance, but we do not have conductance value, but we have a resistance value here. So in the place of G, I can write 1 by R also, right? So you can write 1 by R here into G star. Now they are asking about G star by providing R and K. So you can write G star is equals to K into R right now. So what is K here? K is conductivity. So conductivity is how much here? 0.013 into, and resistance, how much resistance it has? 300. Okay, so you can mention here units, ohm inverse, centimeter inverse into 300 ohms. 300 ohms. Now look at this guys, ohm inverse, ohm can be removed, and then next what we have here, so 2 zeros, so I can write it as 1.3 into 3 centimeter inverse, that is nothing but 3.9, 13 3 is a 39. You can write it as 3.9 as point is there here, so you can write decimal number as it is. So centimeter inverse, just check whether any option we have. Yes, 3.9 centimeters is the first option we have for this question, right? So A is your perfect answer for the question, guys. Guys, is this clear or not? If there is any confusion, please mention. If no confusion, click on the like button once again. Yes, everyone, is this clear or not? If this is clear, click on the like button. Right, we will discuss further. Right, after this we need to discuss now about the conductivity or molar conductivity, more particularly molar conductance. These things we need to discuss. Okay, so now we know the conducting power of all the ions present in unit volume is indicated with symbol K. Okay, so now in that unit volume, what I am saying, in that unit volume, in this unit volume, let us say the volume here is V. Okay, in this unit volume, see this is complete beaker, but I am saying about this unit volume. So in this unit volume only, I have 1 mole of substances. What I am saying, 1 mole of electrolyte. Okay, now what that electrolyte will do? Electrolyte will undergo dissociation and will show some conductivity right now. So the conducting power of all the ions that are formed from 1 molar electrolytic solution of V volume can be given as like this, K into V. Okay, So this is nothing but a molar conductance. What I am writing? Molar conductance. See, why I am indicating with molar conductance here, del M is called as a molar conductance. This is a new term I am using. So why I am using this new term molar conductance? See, the conducting power of, see, molarity we know now. Molarity means what? Number of moles of solute present in V volume of solution. Okay, it means this, if I say this is a complete beaker, okay, if this is a complete beaker, okay, let us say in this unit volume means that unit is 1 I am writing here. Okay, so if I say this is total volume is V means yes, you can need to write here V. Okay, so the conducting power of all the ions present in this unit volume can be considered as like this. K into V gives conducting power of all the ions in unit volume is given as K. If the that volume of that container or that electrolytic solution, if I say V, then K into V it will become, right now. So now what I am saying here, you are taking or you are expressing the concentration in terms of molarities here. So number of ions formed from 1 mole of electrolytic solution present in this V volume of this cell, electrolytic cell, can be taken like this. Okay, right. So you can say del M is equals to K into V. And now we know molarity equals to N by V we are writing. So V can be in liters. Now if you want to write, see, molarity or molar conductivity I am expressing for 1 mole. So number of moles is 1 present in V volume. So if I express V in liters, I should take it like this. But if I express for express in terms of ml, that is I wanted to express in CGS units. Now what happens? M is equals to 1 by V into 1000 it can be written. Okay, so now you can say 1 ml is equals to 1 centimeter cube also. I hope you know this. 1 centimeter equals to 1 centimeter cube equals to 1 ml also. So using that relation, now what I am writing here, 1 by V into 1000 I am writing. This V can be now 1 ml or 1 centimeter cube. So wherever I have V, I am replacing that V with M. So I am writing like 1 by M into 1000. Yes, guys, can I replace V with this? Yes, we can do that, and del M will be giving us K into 1000 by M. So this is a relation we will get for molar conductance, Now what are the units for this molar conductance? See, you have K here. What are the units for K? So units of K is nothing but inverse of resistivity now. So for this you have seen ohm, centimeter. Then for this it will become ohm, centimeter inverse. What it will become? Ohm, centimeter inverse. Okay, right. Now look at here, from this what you can say? Here? See how I got the, see, R is equals to rho into L by A we have written. So from this rho is equals to R into A by L you have written now. So R means rho and centimeter square, this is centimeter. So centimeter like this, ohm into centimeter is a units for resistance, this one, resistivity. Now I am asking 1 by K or 1 by rho, this is nothing but K. So for 1 by rho, that is nothing but K, the units become ohm inverse, centimeter inverse, or ohm inverse, meter inverse are the units. Okay, hope the discussion is clear up to here. Now tell me for this, what are the units for del M they will ask. For this you are writing it as ohm inverse and centimeter inverse. And here you have molarity in denominator. Then for what are the units for molarity? Mole per liter now. So mole per liter. So the final units here you can write centimeter inverse, mole inverse, and ohm inverse, mole inverse, and centimeter square. These are the units in CGS units. Okay, this is in CGS. This formula is for when you are expressing molar conductance in CGS units. Okay, see here, when you are expressing in these units, CGS units, this is the formula. What is the formula you are using? Del M is equals to K into 1000. Yes, guys, these formulas are important here in EAPCET, JEE NEET point of views. Okay, this is what we discussed till now. Next, if I want to express same thing in SI units, so del M becomes K by 1000 into M. So you are replacing 1000 from numerator to denominator. So now what are the units for del M here? So the del m here is changing, units are changing here. So this is ohm inverse, mole inverse, here it is meter square, this is centimeter square, this is meter square. Okay, this is SI unit, that is for CGS units. Now you need to be conscious when you are doing questions whether they are asking in CGS units, SI units. Based on that only you need to decide your formula. Okay, right. Let us solve some questions here. Look at this question. The conductivity of a solution containing 2.08 grams of barium chloride. What they have? Barium chloride. How much quantity? 2.08 grams of barium chloride in 200 ml of solution. What is the conductivity given? K is given 6 into 10 power minus 3 ohm inverse centimeter inverse. Okay, it means CGS units they mentioned. Okay, next what they are asking? Molar conductivity of solution. They are asking about del m. So what you have del m? K into 1000 by m. Why we are using this formula? They want answer should be in ohm inverse centimeter square mole inverse, means CGS. Yes, you can take this. Now what about molarity? Because K value we have directly, and next what about molarity? Yes, how do you get this molarity value? Yes, what is the formula for molarity? Number of moles of solute present in volume of solution. Okay, so number of moles of solute can be written as weight of solute by molar mass of solute into, here in the denominator volume, this can be in liters. If I am writing it in ml, multiply with 1000. Okay, so into 1000 by V, that is volume of solution in ml you can write. So what is the weight of solution given? This is 2.08 grams. Molar mass of BaCl2, if you calculate, see data they have provided here, 137 for barium, for 2 chlorines are there, 2 into 35.5. So this will be 71. Okay, this is 137. So it will be 8 and 0, 2, 208 you will get. So here you will get a 208 number. Okay, into 1000 by what is the volume they have mentioned here? 200 ml. Okay, take here 200 ml. That's it. So it will be how many times? It will be 5 times. Okay, 0, 0. So 10 by 2, 5. Okay, this will be how many times? This will be 100 times. So you got it as 1 by 5 by 100. How much you got? 5 by 100. Okay, and then next from here you can write 1 by 20 as your answer for molarity. So 1 by 20 means m is 1 by 20. So this is simply you can write it as here as K is 6 into 10 power minus 3 ohm inverse centimeter inverse into 10 power 3 by molarity is 1 by 20. 1 here, 20 here. That's it. So 10 power minus 3, 10 power plus 3 is cancelled out. Then next how much you have? 6 into 20, that is 120. So del m we got as 120. But there is no option as 120 because be conscious in what way they are asking. X into 10 power 2. X into 10 power 2 means what you need to do here? So you can write 1.2 into 10 power 2 we can write now. Yes. So what is our X value we got here? 1.2 is your X as a answer here. So you have option A as your 1.2, that will be your answer for the question. Right guys, is this clear? If this is clear, mention clear in the chat box. Right, let us discuss few more questions. Yeah, so can you try this question once? This is very easy. Look at here what they mentioned. The conductivity of 0.25 molar KCl solution at 300 Kelvin is this much. So they have given K value. K is this much. K, conductivity means K, right? And concentration also given directly, molarity is also given. So just a formula substitution. So you take del M as K into 1000 by 1000 by m, that's it. So substitute K value over here, and conductivity of this concentration 0.25 means here you will get your del m, and tell me your answer for this question in the comment box. Those who are watching the live session, mention your answer for this question in the comment box. Number it as question number 1 and give me your answer for this question. Okay, so this is your homework question. Just formula substitute and tell me your final answer, so that you will get practiced like how you are substituting the things. Okay, then next a few more things to be discussed here. Let me show you a few more questions otherwise. Look at this, the conductivity of pure water is this much, the resistance measured for the sample of water, yes. So conductivity K is given, cell constant G star is given. Now what they are asking, very easy na, resistance they are asking. What is the relation? K is equals to G into G star. Okay, so now they haven't mentioned G, they are not asking about G, but they are asking about resistance. So now what you can say, so G means 1 by R now, so you got your K here. So this is G star. So what you need to do, see the conductivity of pure water, K is mentioned, the resistance measured for this sample of water, the conductivity cell is. So they are asking about this resistance R. So R is equals to G star by K. So this could be your simple formula to be used here to get your answer. So substitute the values given here and get me your answer. Okay, again I am providing 4 options here. See, there is simple calculation because all these are values are fixed, 3.75 only. So there is only slight changes here. Just look at these values and tell me what is your answer for the question. Okay, this is your homework question 2 from our discussion. Whatever we have discussed from this is our second question. Guys, see, again you no need of watching any other video if the complete concept is clear, whatever we have discussed till now in the discussion, right? Next, the next we have to be discussed a few more things. Let me tell you the concept here. See, what you have seen till now, molar conductance you have seen. Now one more term I am using here, equivalent conductance. What I am saying, equivalent conductance, that is indicated with del EQ. Okay, this is what del equivalent, EQ means what, del equivalent conductance. Okay, equivalent conductance is also similar to this, but here we are using normality, and here I should express in terms of, here I am using molarity, here I should express in terms of normalities, that's it. So K into 1000 in the numerator and the denominator normality N. Okay, so what are the units for these? Similar to that, you are writing it as ohm inverse. There you are saying mole inverse na, you should say here equivalent inverse. Then next there you are saying it as centimeter square, you can say here centimeter square, same. This is CGS units. Now if I ask for SI units, K into 1 by 1000 by En, you can remember. This is for SI units. Okay, so ohm inverse, equivalent inverse and meter square. These are the units. Okay, right. Okay, now they will be asking what is the relation between molar, like del M, molar conductance, and del EQ, that is equivalent conductance. What is the relation they will ask? So how do you get this? So del M by del EQ will be equals to, simply substitute here K into 1000 by N, that is molarity na, so M here and here K into 1000 by N. So what you can do, this K 1000 can be removed. So simply you have 1 by M in the numerator, so I can write 1 by M. This is 1 by N, I can write here N. Okay, so simply you got del M by del EQ is equals to N by M. What is M and N? What is the relation between them? So normality equals to molarity into N factor, right? So you can take M into N factor and here M. So M got cancelled here. So finally you have del M and del EQ is equals to, how much you can say? N factor. This is equals to N factor, simply N factor. What do we mean by N factor in this case? For example, sulfuric acid I am giving you. So what is the n factor for this? It releases 2 H plus ions now, so its n factor is 2. So for acids, number of H plus ions released by 1 mole of that substance. For bases, number of OH minus comes out of it. For an electrolyte, for a salt, total number of positive charges or total number of negative charges coming out of it are present in it can be considered as its n factor. Okay, when you place the substance in the aqueous medium, what I am saying, when you place the substance in the aqueous medium, the number of H plus ions or OH minus ions or total number of cations or total number of anions released by that substance is considered to be its n factor. That's it. Okay, the discussion is clear now, right? Now tell me, what can be the relation for the sulfuric acid? So del M can be written as 2 times of del EQ. Why you are writing like this? See, its n factor is 2. So this n factor value for sulfuric acid is 2. So that's why del M will be 2 times of del equivalent. Like this we need to write. Okay, right. Let me explain few more things. Yeah. Look at this question, everyone. Look at this question. One more discussion to be done here, that is about Kohlrausch law. Anyways, we will be discussing about Kohlrausch law in the next session, but as of now we will be discussing this one last question and we will be winding up this discussion on molar conductivity, conductance and equivalent conductance. Okay, in the next session we will be discussing on Kohlrausch law and its application, one of the very important topic for your EAPCET JEE NEET exams. Okay, right. So whatever we discussed, yes, all these things are important only. So now look at here, the molar conductivity of 0.02 molar solution of an electrolyte is this much. It means del M value is mentioned. What is that? Del M equals to 124 into 10 power minus 2 S M square mole inverse. Okay, and what is the concentration of that electrolytic solution? That is concentration indicated with 0.02 molar. Okay, next, what is the resistance of same solution? What is the resistance of same solution? It means they are asking about R value. What is the resistance of the same solution? Okay, in ohms, when kept in a cell constant, in a cell of having cell constant this much. So they are asking about R by giving cell constant, that is how much G star is given. How much it is given cell constant? 129 M inverse. Okay, guys, if you observe, they are using SI units right now. So now one more thing, what or how can we relate G star with R? Yes, we have a simple relation, basic, that is the first relation that we have learned here. K is equals to G into G star, right? Now G into G star we have. Okay, so we got our G star value, and the next, wherever I have G, I can write K is equals to G star into 1 by R, because G means resistance and inverse of that resistance is G means conductance, inverse of that conductance is resistance. So wherever I have G, I can write it as 1 by R. Yes, we are making it. Yes, we got it finally. So what you can say here, R can be written from here, R can be written as G star by K. Why I am writing G star by K? Yes, we got our K value. Yes, we will get, definitely K value we will get, and G star value is given. So how do you get this K? Yes, we can calculate K from this del M. So what is the relation? Del M is equals to K by 1000 into molarity, capital M, right? So from here, K is how much? K is how much they mentioned? Yes, we need to find K. Okay, so K is equals to K is equals to del M into 1000 into M, that is molarity. Now what is del M mentioned? Del M mentioned is 124 into 10 power minus 4 into 1000 means 10 power 3. Okay, and what about molarity mentioned? 2 into 10 power minus 2. Yes guys, now if you see this, how it is? If you see this, 10 power minus 4, 10 power minus 2, that is 10 power minus 6, and 10 power minus 6 plus 10 power plus 3. Okay, so bases are same, powers can be added. So now what happens? Minus 6 plus 3, that is minus 3 right now. So 10 power minus 3 you can write into 124 into 2, that is 8, 4, 2, 248 into 10 power minus 3 will be your K. Okay, so you got it in terms of meter, like SI units you got, right? So K value you can write here, G means 129 by 248 into 10 power minus 3. So instead of writing 10 power minus in denominator, you can write here 10 power plus 3 like this. Okay, see 129 twos are, you will get 8, 5, 2, 258, but here we got only 248. So what you can do? So this will be almost not exactly 2 but lesser than 2, that is around 1.9 you will get right now, 1.9 around. Okay, so here 1000 by 1.9, if it is 1000 by 2, 500, but it is lesser than 2 now. 1.9 means how much you will get? Around 500 plus. So what is the 500 plus value? Here we have only option D, 520 is there, so that will be your answer. So 1.9 around 520 will be your answer. So option D is your answer for the question. Hope the complete discussion. So complete discussion of this question is clear right now. Sir, please speak in Hindi. Right guys, those who are watching, see I'm always try to use very basic English right now. It can be comfortable for everyone. So please try to follow it so that everyone can feel it. Right. The next few questions I am giving as a homework, please look into it, and remaining things will be discussed in the upcoming sessions. Okay. So these are some questions I am giving as a homework. Try this question and let me know answer for this question number 3. You just answer me with this question number 3. The next, this one also. Yes, this one also. All these are like homework questions for you. Yes, guys, you need to answer me this based on your understanding. Till now, whatever we discussed, based on that, you can answer me this. Yeah, all these questions, whatever I am highlighting here, showing here, are PYQs of NEET, JEE, EAPCET only, right? Yeah, right. So thanks for watching. Stay connected with our NEET World channel. If you are new to this channel, please click on the follow button and subscribe the channel so that you will get daily updates from our side. Okay, so thanks for watching. Stay connected and share with your friends.